Right, now we see the projectile motion. First you see what do you mean by the projectile. So what do you mean by the projectile? Projectile is nothing but body. Projectile is nothing but body. If any body is projected with an angle theta other than 90 degrees, if any body is projected with an angle theta other than 90 degrees, then that body is called projectile. Or if any body is projected with an initial velocity u and making an angle theta with respect to horizontal, then that body is called projectile. The path of the projectile is a parabola and it is a trajectory. Okay, the path of the projectile is a parabola and it is a trajectory, that we are going to prove it. So parabola equation y is equal to ax minus bx square. So that we are going to prove it. That we can see. So first you see the projectile is nothing but body which is projected with some initial velocity and making an angle theta. That theta is not 90 degrees, other than 90 degrees. Then that body is called projectile. Simple concept. Suppose you see here, suppose this is x axis I am taking and it is y axis, this is y axis. Now the body is projected with initial velocity u, that body is projected with initial velocity u and making an angle theta with respect to horizontal. So the path, then that body is called projectile and the path of the projectile is a parabola like this. So this is a parabola. Now this velocity u can be resolved into two components, that is along horizontal, initial horizontal velocity ux, that is equal to u cos theta. So initial horizontal velocity I am taking u cos theta, and initial vertical velocity along vertical, myself I am assuming that is uy. Uy represents initial vertical velocity, that is or along y axis, that is equal to u sin theta. So initial horizontal velocity is u cos theta and initial vertical velocity is u sin theta. Now see the velocity of the particle or body at any point. If you want to check here, so if you want to check the velocity of the body at this point, see this horizontal velocity, whatever horizontal velocity is there now, ux, that is equal to u cos theta only. Means that horizontal velocity does not change. Why that horizontal velocity will not change? Means that acceleration due to gravity will work either in upward direction or in downward direction. So that acceleration due to gravity is working perpendicular to the surface, horizontal surface. So no horizontal, there is no acceleration due to gravity concept along horizontal. So there is no acceleration due to gravity concept along horizontal. So because of that, the gravity will not work along horizontal. So whatever velocity is there initially, that is u cos theta, here also u cos theta. Anywhere you can check that horizontal velocity does not change. Even at its maximum height, horizontal velocity ux is equal to u cos theta only. Even if you check at this point where it meets again that point, that x-axis, here also you can check that final horizontal velocity, myself I am assuming that final horizontal velocity Vx is also equal to u cos theta. So final horizontal velocity Vx is equal to u cos theta, means horizontal velocity does not change. Okay, now vertical velocity will change. So vertical velocity you see here, so here that vertical velocity will change, and at its maximum height that vertical velocity is 0. Why? Because gravity is working. So gravity is working along vertical So at its maximum height, so this is the maximum height, you can assume it is h. So at its maximum height, its vertical velocity is 0, but body has certain velocity, that is the horizontal velocity, that is u cos theta. With u cos theta horizontal velocity, it completes the remaining half of the parabola. It completes the remaining path, like the remaining half of the parabola. So this is the concept. So see here, I'll repeat, along horizontal, that is u cos theta, and along vertical, that is u sin theta. So u sin theta will change. So why? Because gravity is working in downward direction. So at its maximum height, that vertical velocity is 0, but it has horizontal velocity, that is u cos theta. Even again it meets the horizontal, this x-axis. Here it has the horizontal velocity, final horizontal velocity is u cos theta. And now you can assume the displacement of the particle is called, that is started here and end here. So this displacement of the particle is nothing but range. We call it is the range capital R. We can indicate that is the range capital R. So the horizontal displacement of the particle is nothing but range. Horizontal displacement of the particle is called range. Right. Now see the vertical components and horizontal components, that we can check it. So see here, first I'll write along vertical, you can see. First you see along vertical, or shall I write here? Right. So I'll write here, see along vertical. So in vertical, you see the body is projected in this direction like this. So initial vertical velocity uy is equal to u sin theta, and final vertical velocity vy, final vertical velocity vy is equal to 0. Okay, and a is equal to minus z. Why? Because it is moving in upward direction, and this displacement you can assume it is as a y. That displacement you can assume it is as a y. Now from equation, okay, s is equal to ut plus half at square. S is equal to ut plus half at square. Here s is nothing but y. So here s is nothing but y. Y is equal to, u means u sin theta. That is u sin theta into t, u sin theta into t minus half g t square. Why I am taking minus? A equal to minus g. That acceleration a is equal to minus g. Why? Because upward direction. So this is the equation, vertical displacement equation. Assume it is equation number 1. So vertical displacement y is equal to u sin theta into t minus half gt square. So u sin theta into t minus half gt square. Now you go for along horizontal. So now you see along horizontal. So along horizontal I'll write along horizontal